Hello all, welcome to Btech Creations. In this video, I am going to teach you antenna and its types. So first let me tell you what's an antenna. Before going to definition, let me make you clear what an antenna is. I am sure that all of you have seen an antenna. So imagine this is an antenna, this is another antenna. Okay. So first I am going to talk about this one. So what's an antenna? It's a metallic device, okay, used for radiating or receiving radio waves, or I can say electromagnetic waves. So this antenna is a transition structure between free space and a guiding device. What's a guiding device? Imagine a conductor is there over here. It can be a conductor or a waveguide. The electrical signal is converted to electromagnetic waves or radio waves. The electrical signals from the conductor or waveguide is converted to electromagnetic waves, it's radio waves, and is propagated to free space by the antenna. This is what an antenna is. An antenna is so we can say an antenna is a transducer because it converts one form of energy to another form. Here, the electrical signal from the conductor is converted to electromagnetic waves by the antenna, radio waves by the antenna, and is propagated to free space. From the conductor to the free space, antenna is transmitted. Now the basic classification, we all know that antenna can be classified into two types: transmitting antenna and receiving antenna. So what does the transmitting antenna do? The transmitting antenna converts the electrical signals to radio waves and propagate to free space. And now what does the receiver antenna do? It absorbs the radio waves. It takes the radio waves from the free space and converts to the electrical signals and give it to the conductor or to the waveguide. This guiding device, this connecting device can be a coaxial cable, optical fiber, waveguide, and all. So an antenna is a transducer because it converts one form of energy to another form of energy. Okay, a signal, electromagnetic signal, wave or signal to electric signal. So that's what an antenna is. Now I am going to classify antenna into its three types. The three types are: first one, isotropic antenna. So what is an isotropic antenna? Imagine this is an isotropic antenna. Okay, this radiates equally in all directions. Imagine this is an isotropic antenna. This antenna is radiating equally in all directions. So we can say this is an isotropic antenna. And the radiation pattern is a sphere. Okay, it radiates in a sphere form. Now isotropic source at origin. So the source is at origin. Okay, we are saying that the source exists at the origin. The source is existing at the origin. Hypothetically, lossless antenna is isotropic antenna. Okay, it's hypothetical that it is lossless. It's not practically possible. You know that. So it's a hypothetical isotropic and it's hypothetical antenna, and it radiates equally in all directions. So this is what an isotropic antenna is. I will write the points. So first what we said, radiates equally in all directions. Sorry for my handwriting. Radiation pattern is what? It's a sphere. Radiation pattern is sphere. Third one is, it's a hypothetical antenna. Hypothetical. Why it's called hypothetical? Lossless. We know due to a lot of conditions there will be attenuation. So it's hypothetical. Hypothetical lossless antenna having equal radiation in all direction. Equal radiation in all direction. Okay. Now I am going to the second antenna, which is important: directional antenna. What is a directional antenna? From the name itself, you can understand what's directional antenna. An antenna which radiates to a particular direction than to any other direction. Example, this antenna is radiating this antenna is radiated in this direction more than to other directions. Unlike isotropic antenna which radiates in all directions, this directional antenna has a partiality. It directs radiation only to a particular direction. So let me draw its graph, and I'm sorry guys, the diagram is also very important. Draw the three axes x, y, z. I told you what isotropic source exists at origin. So this is the origin, and a sphere of radius r to uniformly in all directions, and that's isotropic antenna. Now directional antenna. What I said first, in directional antenna, of course it's three-dimensional axis you have to draw. It radiates in particular direction. The intensity is more in a particular direction. So I'm drawing a lobe indicating a radiation of maximum radiation intensity. So this is the biggest, this is my intention to direct to a particular direction, and this is the lobe contain the maximum amount of radiation. So I call it major lobe. Axis Y and Z. Because I told that radiation exists mainly in major lobe, directional antenna, the radiation to a particular direction, that doesn't mean there's no radiation to all other directions. Radiation exists in other directions too, but in minor lobes or side lobes. Why we are calling minor lobes? Because the radiation intensity is minor, it's very low. Though the radiation is for a directional antenna, radiation exists in a maximum intensity in a particular direction, doesn't mean there is no radiation in other directions. There do exist radiation in other directions too, but they are very small. Okay, so we are calling it side lobes. Look, they are exist in sides, and we call them side lobes. All these are side lobes. Okay, side lobes or minor lobes. Now the lobe just opposite to the major lobe is called a back lobe. The lobe existing opposite to the lobe having the radiation of maximum intensity is called back lobe. Okay, I hope it's everyone is clear. The point is clear to everyone. So now let's discuss the points. Directional antenna radiates in particular direction. See, to a particular direction it radiates in particular direction. Sorry for my handwriting. Radiates maximum, radiates in particular direction, radiates maximum in particular direction, and what? Receiving electromagnetic waves more effectively in some direction than others. This directional antenna, there is transmitted directional antenna, receiving directional antenna. Transmitting directional antenna transmits more in one direction, and receiving directional antenna receives more waves from one direction. Okay, imagine this is a receiving antenna. Then what it will do? Unlike from other directions, it receives signals from more signals from a particular direction. Okay, that is directional antenna. It's having partiality. It sends more to a single person and receives more from only one from person. It doesn't receive from everyone coming to it. Only from a particular direction it receives. It's having partiality. Okay, so isotropic antenna is over, directional antenna is over, and now we go to the third one, omnidirectional antenna. Omnidirectional antenna. So what's an omnidirectional antenna? It's a special type of directional antenna. Okay, omnidirectional antenna is special type of a directional antenna because here the major lobe of omnidirectional antenna is in a plane. Okay, I'm saying that the major lobe of omnidirectional antenna is in a plane. Here you see there is one lobe, right? Here in omnidirectional antenna, I told it's a plane. So how can you describe it in a plane? This is an axis, guys. In directional antenna, it's towards one direction, towards an axis. But in omnidirectional antenna, it's in a plane. Okay, not to an axis. No, it's not like that. It's not like that. It's in a plane. Okay, so and remember, guys, there is no back lobe in the omnidirectional antenna. There is no back lobe in omnidirectional antenna. I will show you. This is a plane. See. This is a plane. This is a plane. Okay, and now there are side lobes. Now I hope you can understand why there is no back lobe, because it's towards a particular direction. We can say there is a lobe opposite to this, so it's a minor back lobe. But can we say over here? No, because it's in a plane. The lobe exists in a plane, not towards a particular direction like this. So there is no back lobe for omnidirectional antenna. It radiates in plane. Now, this is what? This is a major lobe. It exists in a plane. This is the lobe having the maximum information. That's the radiation with maximum intensity. So, this is major lobe existing in XZ plane. See, X to Z, XZ plane. Major lobe in XZ plane. Now, these are what? Side lobes. Yes, these are side lobes or minor lobes. So, here exists in a plane, here in a direction. It's omnidirectional. Omni, it's more, right? Here one direction, here it lies in a plane. So, drawing two radiation intensity, sharing it, two big major lobes, and sharing it in a plane, side lobes, and the major lobe is existing in XZ plane. It's special type of directional pattern, special type of directional pattern, and directional in elevation plane. That's important. That's very important. You have to learn these 2 points. You have to write just like this: directional in elevation plane and non-directional in azimuth plane. Directional in elevation plane, deep, and a non-directional in azimuthal plane. So these are the 3 types of antennas, and we had discussed what an antenna is. It's very important and it can be asked, say, for 3 to 4 marks. Thank you for watching this video in Btech Creations.